Section 7.2 homework, similar polygons. We're supposed to draw the following, mark the congruent angles. We got triangle cat is similar to triangle dog. Let me draw a triangle. Any random triangle will do. I'm going to mark the angles. 1 arc, 2 arc, smiley face. So if you look at this, C and D are in the same spots. So I need to make sure that C and D are in the same spots. A and O are in the same spots. And T and G are in the same spots. Now this is not enough to show that these two triangles are similar. Corresponding sides have to be proportional. So let me add some numbers to this. Let's say this is 3, 4, and 5. If the dog triangle, let's say, is 10 times bigger than the cat triangle, I just need to take each corresponding side and multiply it by 10. And now I know for sure that the corresponding sides are proportional. That makes these two triangles similar. Parallelograms, dork, in face are similar. Excuse me, I thought I was going to sneeze. So the last thing you want to hear or feel on your face while you're listening to this. So parallelograms, opposite sides are parallel. Remember that corresponding angles have to be in the same positions. In a parallelogram, opposite angles are congruent. So this currently shows we have two parallelograms and that corresponding angles are congruent. We need to also show that corresponding sides are proportional. So I'm going to pick some random lengths for these sides. Remember, in the parallelogram, opposite sides are the same length. Then I'm going to say that face is twice as big as dork. So if I double each of those numbers, I get this. Those two are similar. Number 3, trapezoids. Trapezoid has one pair of parallel sides. Those are called bases. Mark these angles. I'm going to draw a similar one. Trapezoid back, similar to trapezoid hair. Notice corresponding angles are in the same positions. Now I need to write down some lengths of sides and make sure that they are proportional. So let's say that I say this is 4 and 6. They have to be different lengths, the bases. And let's say that hair is half the size as back. It's going to make this 2 and 3. Remember, pictures aren't drawn to scale. Let's say that this fellow over here is 8 and this is 10. Half of that's going to be 4 and 5. Next set of directions. The following triangles are similar. Fill in the blank using the proper order. Find the scale factor. I'm going to redraw this triangle so that it's in the same position as ABC. That the corresponding angles are in the same positions. ABC has 41 degrees in the bottom right, 56 in the bottom left. Third angle theorem, which I don't know if we've covered yet, says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. There's a really easy proof of that. If you add up all the angles in a triangle, you get 180. So you add up the same two numbers twice, the third number is going to be the same each time. So angle E, angle F, and angle G, even if we didn't know that those third angles G and C were congruent, we know they're similar because the direction says that they are. FG is 10. Now that we've written the pictures so that the corresponding parts are in the same positions, finishing the statement triangle EFG is similar, so EFG. It's going to be triangle ABC. Now it's a scale factor. You have to always know in which order the scale factor is supposed to be, so the question has to ask, since our similarity statement has triangle EFG first, our scale factor is going to have a length of a side for EFG on the top. So it's going to be triangle EFG on the top, triangle ABC on the bottom. A length of a side, I only know one length of the side in EFG, that's 10. Its corresponding side is 7. The scale factor is 10/7. Number 5, same directions. We know they're similar, we got to determine how they're similar. We have vertical angles right here. We have two parallel lines denoted by those little triangle looking things. If you take a transversal like so, that makes this angle M and this angle F alternate interior angles. The alternate interior angle theorem says if you got two parallel lines cut by a transversal, then alternate interior angles are congruent. For a similar reason, angle N is congruent to angle E, alternate interior angle theorem. I'm going to redraw this picture so that the angles are in the same positions. This removes any doubt when you do these problems. My smiley face on the right, my frowny face on the bottom, with the one arc on the left. N is the frowny face. M is the smiley face. G is the one arc. Add the measurements of any sides. From N to G is 56. Okay, so I'm comparing these two triangles. We got triangle GFE, GFE, so I'm going to go triangle GMN. The order matters. Scale factor, since GFE came first, it's triangle GFE on the top. Then we got triangle GMN on the bottom. I only know the length of one side in GMN, which is 56. Its corresponding side is 126. This reduces, so we should reduce it. I can divide both of those by 2 for sure. It's going to give me 63 over 28. Let's see, I can divide both of those by 7 and get 9/4. Scale factor here is 9 over 4. Number 6, I assume it's the same instructions. We know they're similar. So check this out. This angle and this angle have to be the same because we got two parallel lines cut by a transversal. It's a corresponding angles postulate. This angle has to be the same as itself. Congruence of angles is reflexive. This angle has to be the same as this angle, once again because we got two parallel lines cut by a transversal, they're corresponding angles. Let's see, I'm not going to redraw this one, although I encourage you to redraw them most of the time. So VUT because the corresponding parts are in the same positions. That's what I'm not going to. VUT goes this way. So when I name the similar triangle, I'm going to go in the same order. So it's going to be VBA. Scale factor, VUT was first. It's going to go on top. Triangle VBA was second. It's going to go on the bottom. I got lots of numbers to choose from here. I'm going to choose the 14 and the 98. So VUT, side UT is 98. Side BA is 14. I can divide both those by 2 for sure. It's going to give me 49 over 7. Oh, look at that. I can divide them by 7 also. So the scale factor is 7 to 1. Number 7. Each pair of polygons is similar. Excuse this. This should say is, not are. It's one pair, singular, is singular. Each pair of polygons is similar. Find the missing length. Fortunately, these pictures are drawn so that the corresponding parts are in the same positions, because if you look at the angles, corresponding angles are in the same spots. We're trying to find x, well, question mark. I don't like question mark. I'm going to change that to an x. So I picked two corresponding sides. 42 is to 35, as 24 is to x. Then I solve this equation. I'm going to choose to reduce the fraction on the left first. I can divide both of those by 7 and get 6/5 is 24 over x. I can then multiply both sides by 5 and x. On the left, the 5's cancel. On the right, the x's cancel. Now check this out. I could multiply the 5 times the 24. I'm going to actually withhold doing that for a moment. I'm going to divide both sides by 6 to get x by itself. Now I can do some canceling here. 6 goes into itself once, goes into 24 4 times. Now I got 5 times 4, which is 20. That is one way to do this problem. There are many other ways to make this proportion. In fact, there are, I think, 8 different ways to write it correctly. And there's a bunch of ways to write it incorrectly. That's one such thing. Same directions. Find the missing measure. I'm going to call that missing measure x instead of a question mark. Corresponding angles are in the same positions already, which is great. So I got lots of choices here. I'm going to go 7 is to 28 as 4 is to question mark. 7 is to 28 as 4 is to x. 7/28 reduces to 1/4. We're going to multiply both sides by 4 and x. On the left, multiplying and dividing by 4 gives you 1. On the right, multiplying and dividing by x gives you 1. So we end up with x equals 4 times 4, which is 16. Once again, there's many ways to make that proportion at the beginning. Let me just show you a couple more. You could have wrote 6 over 24 equals 4 over x. Could have wrote 24 over 6 is x over 4. This next one may seem strange, but it also works. We could have written 6 is to 4 as 24 is to x. So in that case, we're taking two corresponding sides in the same triangle and setting them equal to two corresponding sides in the other triangle. So that also works. Number 9. This is going to require us to redraw these pictures because they're so complicated and jammed up. So we're going to know how they're similar. Angle R is congruent to itself. angle RCD is congruent to angle CTS. Why? We got two parallel lines and a transversal. Those smiley faces are corresponding angles. They're congruent. For the same reason, corresponding angles are congruent. These angles are the same. Let me redraw each of these triangles. You don't need to draw them to scale, but you need to draw them so the corresponding parts are in the same positions. Triangle RDC, frowny, smiley, one arc, 30, 27, 18. Bigger triangle, frowny, smiley, one arc, R, S, T. So RT is 36, TS is 24. We're supposed to find the length of RS. Once again, different proportions you can set up. You can do this in lots of ways. I'm going to go 27 and 36 and RS and 30. So I'm going to do the bottom triangle, RST on top. So 36 is to 27 as RS is to 30. Once again, there are so many different proportions you could write for this that are true. I'm going to simplify the right side because I got some big numbers. 36 over 27, I can divide both of those by a 9er and get 4/3. I'm then going to multiply both sides by 30 only. You could also multiply by 3, but I think that you'll find it's pointless. 30 divided by 30 goes 1 time. 3 goes into itself once, goes into 30 10 times. We no longer have any fractions. So now we have 10 times 4 equals RS. Therefore, RS is 40. Moving on. Number 10, the pictures are not drawn in the same orientation. We want to fix that. I'm going to redraw this triangle down here so that my smiley and my 2 arc and my star are in the same positions. At the corner of a star and 90, not at the corner. Star and 90 are corners. That's not a 90. 2 arcs and star, that segment has a 9. 1 arc in a star is 15. 1 arc in a smiley, also 15. So I'm comparing now the triangles on the left. I'm going to call this question mark X. So X is to 9 as 25 is to 15. Corresponding, corresponding. Once again, many different ways to write that proportion. I'm going to simplify the fraction on the right by dividing the top and bottom by 5. Then to get X by itself, I'm going to multiply both sides by 9. 9 goes in the 9 at 1 time. 3 goes in the 9 3 times. So we end up with X equals 5 times 3, so X is 15. Number 11. The following polygons are similar. Find the value of X. Do not assume this is a rectangle. It looks like a rectangle, but geometrically speaking, there is not enough information to conclude it's a rectangle. It's true the opposite sides are the same length. We have no reason to believe we have 90-degree angles. So I'm going to redraw the pictures so that the angles are in the same positions. Not drawing it to scale, because the scale doesn't matter. Going to make a 1 arc in the top left, 2 arcs in the top right, star in the bottom right, smiley face in the bottom left. I'm redrawing. In between smiley face and star is 24. In between smiley face and 1 arc is 12. So comparing the two triangles on the two polygons on the left, the quadrilaterals, x plus 19 is to 12, as 15 is to 24. I'm going to simplify the fraction on the right. If you choose not to simplify your fractions, it's fine. You're just going to have bigger numbers. So I can divide the top and bottom of that by 3 and get 5/8. I'm going to multiply both sides by a 12 and an 8. You could just choose, you could choose smaller numbers than 12 and 8 and they would work, but I don't want to add more to your mind here. On the left, the 12s cancel. On the right, the 8s cancel. So we get 8 times x plus 19 equals 5 times 12. Still got kind of big numbers, which is unfortunate. Oh well. So distribute 8 times x is 8x. 19 times 8, 8 times 9 is 72. 8 times 1 is 8, plus 7 is 15. So we get plus 152. 5 times 12 is 60. Tell you what, this is not turning out to be pleasant. If I subtract 152 from both sides, I get 8x equals, I think 98. I think I messed up someplace. Let me just glance at the old answer. I don't have an answer on this. Let me just glance back and make sure that I wrote things down correctly. 19 plus x over 12, 15 over 24. Can divide both of these by 5. Oh, I can't divide, no, divide them by 3. That wasn't my mistake. Gives me 5 over 8. 8 times 19 is 152. That works. Alright, so I guess this is just what it is. Make sure I subtracted right. 98 plus 152 is 160. That's 260. I'm sorry. It's early. 98 plus 60 is 158. This is pretty embarrassing, to be honest with you. 152 minus 60 is going to be 2. It's going to be 92. This should be 92. To confirm, 92 plus 60 is 152. Yay! So then if we divide both sides by 8, we get 92 over 8. And this reduces. I can divide both the top and bottom by 2 for sure. 92 divided by 2 is 46. I can divide those by 2 again and get 23 over 2. Wow, what an adventure. Now, I didn't do that intentionally. I am ashamed of it. But here's how this could have been avoided. So maybe I did do it intentionally. Or maybe I didn't do it intentionally. The world will never know. At this point, going back to this part of the problem, I could have had smaller numbers if I didn't multiply by 12 and 8. Let's say I multiply by 12 first. Obviously on the left, the 12s cancel. On the right, 8 and 12 have a common factor of 4. So 4 goes into 8 2 times, 4 goes into 12 3 times. Then I could multiply both sides by 2. On the right, the 2's cancel. That would end up giving me 2 times x plus 19 equals 3 times 5. It's going to be 2x plus 38 equals 15. 2x equals 23 negative. Well, this should be negative over here. And then x is negative 23 over 2. Choosing the right things to multiply both sides by makes your life easier, as evidenced by the horrendous arithmetic that I did on this problem. Number 12, corresponding parts are in the same positions. It looks like, it doesn't look like that at all. I'm going to redraw this picture down here, so it's just like this one. Corresponding parts in the same positions. I got 90, 3 arc, 1 arc, and 2 arcs. Between 3 arcs and 90 is 7. Between 2 arcs and 90 is 7. Between 1 arc and 2 arc is 8. Between 1 arc and 3 arc is 3. The directions said they were similar. Let's pair 2 corresponding parts. 7x minus 8 is to 8, as 18 is the 3. Well, 18 over 3 reduces to 6. We could then multiply both sides by 8. Eights cancel on the left. We get 7x minus 8. 6 times 8 is 48. Add 8 to both sides. You get 7x is 6. Divide both sides by 7, and you get x is 8. 13. So, this is congruent to itself, angle P. Angle PNM is congruent to angle PRQ. That's because we got 2 parallel lines cut by a transversal. They're corresponding angles. For a similar reason, angle PMN is congruent to angle PQR. 2 parallel lines transversal. They're corresponding angles. I'm going to redraw these little pictures. Make sure I don't draw them too big, because I got work to do. Don't want to draw them too small, because I want to be able to read them properly. Putting the corresponding angles in the same position. The small triangle is triangle PNM. The large triangle is triangle PRQ. PN is 30, PM is 27. PQ, Pikachu, is 36, and PR is 5x plus 10. 30 is the 5x plus 10, as 27 is the 36. I'm going to put my variable on the top, so I'm using the triangle on the right on top in both cases. So just confirm that both of these are from the triangle on the right. They are. Both of these are from the triangle on the left. It's important that you have relationships horizontally and vertically. You should have no relationships diagonally. The fraction on the right reduces. I can divide both 36 and 27 by 9 and get 4/3. I'm going to then multiply each side by 30. On the left, 30 divided by 30 cancels. On the right, 3 goes into 30 10 times. So I end up with 5x plus 10 equals 4 times 10. 5x plus 10, therefore, equals 40. So 5x is 30, so x is 6. 14. These are vertical angles, they're congruent. I'm going to redraw this triangle so that the corresponding parts are in the same positions as the top triangle. Let's see, U is 1 arc, S is smiley face, T is 2 arcs. SU is 77. Corresponding, TS is 121. Corresponding. So 11x plus 2 is the 77, as 55 is the 121. Fraction on the right can be reduced again. I can divide both those by 11 and get 5 11s. I could then multiply both sides by 77. When I do that, on the right side I end up with 7, because 77 divided by 11 is 7. So I end up with 11x plus 2 equals 5 times 7. That's 11x plus 2 equals 35, which means 11x is 33, which means x is 3. 2 more. Oh, this has got an exponent in it. Exciting. These pictures are already drawn so that corresponding angles are in the same positions. So x squared is to 4, as x plus 1 is, x plus 3 is to 1. Welp, I'm going to multiply both sides by 4. On the left, the 4's cancel. So I end up with x squared equals 4 times the sum of x and 3. If I distribute that, I get 4x plus 12. How do you solve an equation in which you have exponents for variables and different exponents for the same variable? For example, the 4x is actually 4x to the first. A squared and a first are different. Well, you solve it the same way every time. You get 0 by itself by moving all the terms on the same side, and then you factor. This is a trinomial, 3 terms. It factors into a binomial times a binomial. If you're lucky, the leading coefficient is a 1. We're lucky. So we just take the square root of x squared, and that goes in the first position. We need 2 numbers that multiply to get negative 12 and add to get negative 4. How about negative 6 and plus 2? Once you've factored it, you set each factor equal to 0, and you solve each of those little fellas. Let's just check. Sometimes we get answers in geometry that don't make sense with the picture. We're thinking the x could be 6 and negative 2. If I put a negative 2 in here, I'm going to get 5, which is positive. If I put a negative 2 in here, I'm going to get 4, which is positive. So that works. If I put a 6 in, I get 36, and over here I get 9. Those both make sense. So this answer actually has 2 answers. X is negative 2, or it could be 6. This is not an ordered pair. You cannot put parentheses around those. That's only for different variables. 16, arrows. Yummy. So corresponding angles are already in the same positions. x is the 3 as 2x plus 9 is the x. You can make this equation in different ways, but every time that you multiply stuff together, when your fractions are done, you should have the same thing. I'm going to multiply both sides by 3x. That will get rid of my 3's on the left and my x's on the right. So I get x times x equals 3 times 2x plus 9. X plus x is x squared. Distribute the 3, we get 6x plus 18. Just like the last problem, this is a quadratic. We need to get all the terms on the same side and factor it. We are lucky again, this is a trinomial which the lead coefficient is 1. So in the first spot of each binomial, put x, which is the square root of x squared. Then we got to figure out two numbers that multiply to get negative 18. Same two numbers add to get negative 6. Well, that would be, let's see. Negative 18 and 1, that doesn't work. Negative 9 and 2, that doesn't work. Negative 6 and 3, that doesn't work. Let's make sure I wrote down this correctly. Oh, check this out. 3 times 9 is not 18. Boo! It's a 27. Changes this to a 27, which means we're trying to multiply to get 27, not 18, you silly wabbit. Tricks are for kids. So negative 27 and 1, nope. Negative 9 and 3, yep. This work here is optional. If you're having trouble finding the answer, you should make a list of all the things that could work. So set each factor equal to 0, because you're my hero. And we get x is 9 and negative 3. In geometry, you need to check to make sure those answers make sense. Negative 3 doesn't make sense. If we take a negative 3 and put it in here for x, it's saying this length is negative 3. That is bonkers. Put 9 in, we're going to get positive answers all the way around. So negative 3 is not the answer, but x equals 9 is. That concludes that assignment.